Welcome to this explainer. Today we're demystifying phase 7.2 of the system's life cycle. Now I know what you might be thinking. System design rules sound, well, a little dry, right? But stick with me, because we're going to turn this into a really fascinating, highly structured journey of data. If you've ever wondered how the digital world behind your screen is actually built, you are absolutely in the right place.
All right, let's just dive right into this blueprinting stage. This phase happens right after an existing system is analyzed, and it's basically where the systems analyst sits down to plan exactly how our new system will look and function. We're shifting gears here. We're moving from simply understanding a problem to, actively building the architecture that's going to solve it. To make sense of all this, we're going to follow a single piece of data on its chronological journey through 4 critical phases: capturing input, passing through the validation filter, organizing it into storage, and finally, presenting the output.
I love how this visualizes our roadmap. Think of data almost like a physical object, like a little block moving along a conveyor belt in a high-tech factory. To truly wrap our heads around system design, we literally have to trace this exact flow of information, from the very second it's created all the way to the moment it's consumed.
So let's kick things off with step 1, capturing input, or designing the gates. This is the entry point for absolutely all information entering our new system. Whether you're dealing with a physical piece of printed paper or a digital screen on your smartphone, the primary design objective here is totally singular. These data capture forms act as the ultimate gateway. Their job is to funnel information into the system as correctly and efficiently as possible, right from the get-go. Because, let's be real, if bad data gets in here, the whole system suffers down the line.
Now, when we compare physical paper to electronic forms, we see how the design constraints dramatically shift. On paper, designers have to rely on static visual cues. You know those rigid little character boxes that forcefully try to make you write legibly? Yeah, a universal human frustration. Or they use tick boxes for simple binary choices like male or female. But when we move to computer and online forms, man, it's a game changer. We unlock dynamic user interface elements. We can use drop-down menus to strictly control what a user can select, radio buttons, and, most importantly, automatic validation that checks your work in real time.
Think about it this way. By forcing a user to pick a country from a drop-down menu, the system completely prevents spelling errors before the data even touches the database. You literally cannot misspell Canada if the form only lets you click it from a pre-approved list. It's brilliant.
Okay, so once our data is captured at the source, it hurtles down the pipe and hits step 2, the validation filter. I like to think of this as the bouncer at the door of our system.
Now, the crucial point to remember here is that validation actually doesn't care if your data is perfectly accurate. It's just an automatic computer check that acts as that bouncer, checking if the data is sensible and reasonable based on strictly predefined rules. Imagine a mechanical sieve. If a user types in their age as 400, the system violently rejects that data as completely unreasonable because obviously humans don't live to be 400. But if the user accidentally types an age of 42 when they're actually 24, well, that data slips right through. Why? Because 42 is a perfectly sensible age. Validation catches the impossible, not the merely incorrect. To enforce these rules, analysts design 6 specific diagnostic checks, and I guarantee you interact with these every single day. There's the length check, which is the one frustratingly demanding your new password be exactly 8 characters. There's the range check, making sure your birth month is firmly between 1 and 12. Type checks ensure your name doesn't somehow contain numbers. And check digits. These are brilliant little extra numbers tacked onto barcodes, specifically designed to instantly spot if a tired cashier makes a typing error.
All right, moving right along to step 3, organizing data, the storage vault. Now that our data has survived the validation bouncer, by proving it's reasonable, it needs a permanent, highly organized home.
Welcome to the storage vault. Inside a database, data isn't just thrown into a messy pile, right? It's rigidly packed into a hierarchy. The largest container is a file representing a complete data set, like an entire school's database. That file is made up of individual profiles called records. Think of one record as one complete student. And finally, that record is sliced into specific pieces of partitioned data called fields, like a first name or a phone number.
But here's the problem. Databases can be absolutely massive. What happens when you have 3 students in the exact same school, all named John Smith? To prevent total system confusion, we absolutely must assign a primary key. This is a unique field required in every single file that allows an individual record to be mathematically identified without any ambiguity whatsoever.
The primary key acts exactly like a unique mathematical key, cutting through massive walls of overlapping data to retrieve the exact records you need. It's exactly why you have a unique student ID, or a social security number, or a specific customer account number. It completely eliminates the ambiguity of shared names.
Furthermore, to store this data efficiently and to actually make those validation rules we talked about earlier work, every single field must be locked to a rigid data type. You have alphanumeric or text for things like names and addresses. You've got numeric types, integers and decimals, so the computer can actually perform mathematical calculations. Then there are Boolean types for simple, fast, binary, true or false, yes or no answers, and date/time for storing specific calendar marks. Basically, you simply cannot put a word into a numeric calculation field. It just won't work.
When we blueprint a real commercial product inventory, you can see these rules acting in perfect harmony. The product code is clearly marked as our vital primary key to identify the item. The price field is strictly locked as numeric, specifically currency, so we can calculate totals later. And notice the field length limits. The year of manufacture is restricted to exactly 4 characters to save storage space and proactively prevent invalid entries.
Finally, our perfectly organized and validated data is pulled out of storage for step 4, presenting output, the final display. The way we output information dictates exactly how the system communicates back to the end user. This data flow branches into 2 entirely different design philosophies based on the medium of consumption: digital screens or physical printed reports.
And the design constraints here are completely different. For screens, the user interface must utilize the full space without feeling cluttered. It prioritizes readable fonts and uses intentional negative space to prevent digital fatigue. On the other hand, printed reports, they're all about data density. They require structural anchors like headers, footers, page numbers, and really dense table formats to convey as much information as efficiently as possible on a physical sheet of paper.
Bringing our entire data journey full circle gives us a unified system architecture. It's pretty amazing when you step back and look at it. Information is carefully constrained at the input form, aggressively filtered for reasonability by the validation sieve, structured strictly by primary keys and data types into the storage cylinder, and then dynamically presented back out based on whether the user is looking at a monitor or a piece of paper.
It leaves us with a fascinating realization, doesn't it? Every single app you use, every website you visit, relies on this exact journey. If our data is truly only as good as the design rules that capture and validate it, how vulnerable are the everyday systems you rely on to a single, poorly designed input form? I hope this explainer helps you see the invisible digital architecture all around you in a whole new light. Keep observing and keep learning.